Welcome to BKW Physics. I'm Mr. McConley. We're going to do the first left-hand rule of magnetism. So a guy named Hans Ørsted, around 1820, he noticed something interesting. He had a circuit set up, and when he brought a compass near the circuit, the needle of the compass went crazy. It started twisting different ways, and it didn't make sense anymore. It wasn't pointing north anymore. And so the obvious conclusion is, well, if the compass is being affected by the circuit must be producing its own magnetism. And I guess I'll just say product. And if you remember when we watched a video for the people in class, Michael Faraday, they showed him actually working through this concept. And he was, they were drawing the lines on the video, the Discover video we watched about Einstein, but it had Michael Faraday in it. So he was also had a lot to do with this. But here's how the rule works. If you take your thumb and you point it in the direction of the electron flow, and then you take your fingers and you allow them to bend naturally. I know some people can bend their fingers backwards and stuff, but naturally means, like bending towards your palm. Okay? The natural way your fingers bend is the magnetism direction. So let's play this out here. In this diagram here, let's say the electrons are coming out of the battery and going this way. So if right here at this point I decide to use my left hand rule, I take my left hand, I put my thumb in the direction that the electrons are flowing, see, following like this, and then my fingers are free to move, and if I freely wrap them around the wire, see the way my fingers are wrapping this way, in a 3D sort of sense, you can see that the magnetism is going whoop over the wire like that. Are you seeing that? Like, in other words, it's going into the board up here and out of the board down here. The magnetism is wrapping right around that wire, and that's why we follow it over here to where Hans was playing with his compass. That's why the compass was going crazy, because the compass was experiencing magnetism that was going around the wire like this, and so it was taking the needle. It was just swinging around. The needle was trying to align itself with the direction of the magnetism. I got time to draw one more picture here. So, if you had this set up here, you had a wire, and you ran that wire through a piece of cardboard, let's say. Okay? So, there. Now, I ran it through a piece of cardboard. You with my diagram? And so on that piece of cardboard, I can lay down some compasses. I'll lay down 3 of them. If I tell you that the electron flow is down this way, so this wire is hooked to other stuff. I'm just showing you a cutout, a little piece of it. If I show you that the electron flow is that way, you tell me which way the compasses are pointing. So do a real quick here. Get the left hands fired up. And which way are all those compasses pointing? Now they're each going to be probably pointing a different direction, but we'll go through and we'll do each one and you can tell me which way each one is pointing. Time's up. Alright, so what do you got? This compass right here.
Diagonal along the center.
So I follow my thumb like this, okay? Like this. Like this. You can turn your body whichever way you have to. But I'm going to turn it this way so you can see that my fingers are going right. So this is going to kind of be going this way, right? How about this one? So I'm going to arrange myself this way. And like this, right? And the last one, we're kind of starting to loop now. So what you're noticing is that generally speaking, magnetism why the application. This is why, if you're setting up wires for a big concert, you've got speakers and microphone wires and electrical wires, and you're running all those up to the stage and back to the sound booth, you gotta be careful how you run those wires. Because each of those wires, once the electricity starts flowing through it, creates its own magnetism. And that magnetism can affect the wire that's the next door neighbor. What happens when one wire starts affecting another wire? What do you hear? That really loud ringing, feedback. Because what's happening is all of a sudden, the sound information, which is also traveling because of magnetism, is trying to go down the wire, it's being affected, and you get feedback. For today,